Overview. Object-oriented Java OOPS concept. Java OOPS concepts, a comprehensive overview. Object-oriented programming, OOP, is a programming paradigm that revolves around the concept of objects. These objects can represent real-world entities or abstract concepts. Java is a purely object-oriented language, meaning everything in Java is an object. Core OOPS concepts. Encapsulation. Bundling data, attributes, and methods, behaviors, within a single unit called a class. Protecting data from external interference through access modifiers, public, private, protected. Example, a car class encapsulates properties like color, model, and methods like start, stop. Inheritance. Creating new classes, subclasses, by inheriting properties and methods from existing classes, superclasses. Promotes code reusability and hierarchical relationships. Example, a dog class can inherit properties and methods from an animal class. Polymorphism. The ability of an object to take on multiple forms. Two types. Compile-time polymorphism, overloading different methods with the same name but different parameters. Runtime polymorphism, overriding redefining methods and subclasses with the same signature as in the superclass. Abstraction. Focusing on essential features while hiding implementation details. Achieved through abstract classes and interfaces. Example, a car class can have an abstract method start engine, whose implementation varies for different car models. Additional concepts. Class, a blueprint or template for creating objects. Object, an instance of a class, representing a real-world entity. Methods, functions associated with a class, defining object behavior. Attributes, data members of a class, representing object properties. Constructor, a special method used to initialize objects. Interfaces, contracts defining methods that classes must implement. Packages, a way to organize classes and interfaces into namespaces. Example. Java. Class animal. String name. Void eat. System.out.println, name plus is eating. Class dog extends animal. Void bark. System.out.println, woof. Public class OLP example. Public static void main, string args. Dog equals new dog. Dog.name equals buddy. Dog.eat. Dog.bark. In this example, animal is a base class with name attribute and eat method. Dog is a subclass inheriting from animal and adding bark method. OLP example demonstrates object creation and method calls. Benefits of OLP. Code reusability. Inheritance promotes code reuse. Modularity. Encapsulation leads to well-structured and maintainable code. Flexibility. Polymorphism allows for adaptable code. Problem solving. OLP models real-world problems effectively. Java classes/objects. Show drafts. Java classes and objects, the building blocks of OLP. Classes. A class in Java is a blueprint or a template for creating objects. It defines the properties, attributes or data members, and behaviors, methods, that objects of that class will have. Think of a class as a cookie cutter. You can use it to create many cookies, objects, that all have the same shape and ingredients. Structure of a class. Java. Class my class. / attributes, data members. Int x. String name. / methods, behaviors. Void method 1. // int method 2, int a, int b, // code. Attributes, variables that store data associated with an object. Methods, functions that define the actions an object can perform. Objects. An object is an instance of a class. It is a concrete realization of the class, with its own values for the attributes defined in the class. Think of an object as a specific cookie created from the cookie cutter. Creating an object. Java. My class obj equals new my class. My class is the class name. Obj is the object reference variable. New my class creates an object of the class my class. Accessing attributes and methods. Java. Object x equals 10, / accessing attribute. Obj.name equals Alice. Object method 1, / calling a method. Example, a simple car class. Java. Class car. String color. String model. Int year. Void start. System.out.println, car started. Void stop. System.out.println, car stopped. In this example, car is a class representing a car. Color, model, and year are attributes of a car. Start and stop are methods that define car behavior. To create a car object. Java. Car my car equals new car. My car.color equals red. My car.model equals sedan. My car.year equals 2023. My car.start. Key points. Classes are the blueprints, objects are the actual instances. Objects have state, values of attributes, and behavior, methods. You can create multiple objects from the same class. Objects interact by calling methods on each other. Java attributes, the building blocks of objects. Attributes, also known as fields or data members, are essential components of a Java class. They define the characteristics or properties of objects created from that class. Think of them as the variables that hold the data associated with an object. Types of attributes. Instance attributes belong to individual objects of a class. Each object has its own copy of these attributes. Declared within the class body but outside of any method. Java. Class car. String color. Int year. Double price. Static attributes belong to the class itself, not individual objects. Shared by all objects of the class. Declared using the static keyword. Java. Class car. Static int count equals 0, / number of cars created. String color. Int year. Transient attributes. Not serialized when an object is serialized. Useful for data that doesn't need to be persisted. Declared using the transient keyword. Java. Class employee. Transient int password, / don't serialize password. String name. Int ID. Access modifiers. You can control the visibility of attributes using access modifiers. Public, accessible from anywhere. Private, accessible only within the class. Protected, accessible within the class and its subclasses. Default, accessible within the same package. Example. Java. Class person. Public string name, / accessible from anywhere. Private int age, / accessible only within the person class. Protected string address, // accessible within person and its subclasses. Int ID, // accessible within the same package. Important considerations. Choose appropriate data types for attributes based on the data they represent. Consider using encapsulation to protect data integrity by making attributes private and providing public methods to access and modify them. Use meaningful names for attributes to improve code readability. Java class methods. Methods are the dynamic part of a class, defining the behaviors or actions that objects of that class can perform. They encapsulate the logic and operations associated with an object. Types of methods. Instance methods belong to individual objects of a class. Accessed through object references. Can access both instance and static members of the class. Java. Class char. String color. Void start. System.out.println, char started, plus color. Static methods belong to the class itself, not individual objects. Accessed directly using the class name. Can only access static members of the class. Java. Class mathutils. Public static int add, int a, int b. Return a plus b. Method structure. Java. Public static / void return type method name, parameter list. / method body. Public / private / protected, access modifier determining visibility. Static, keyword for static methods. Return type, data type of the value returned by the method, or void if no return value. Method name, name of the method. Parameter list, list of parameters passed to the method. Method body, contains the code that defines the method's behavior. Example. Java. Class rectangle. Int length. Int width. / instance method. Int calculate area. Return length * width. / static method. Static int calculate perimeter, int length, int width. Return to * length plus width. Key points. Methods define the actions an object can perform. Instance methods operate on specific object instances. Static methods are associated with the class itself. Choose appropriate access modifiers to control method visibility. Use meaningful method names to improve code readability. Java constructors, initializing objects. A constructor in Java is a special method that is used to initialize objects. It is called automatically when an object of a class is created. Unlike other methods, a constructor doesn't have a return type, and its name must match the class name. Key characteristics of constructors. No return type. Constructors don't have a return type, not even void. Same name as class, the constructor's name must match the class name. Implicitly called. When you create an object using the new keyword, the constructor is called automatically. Can be overloaded. You can have multiple constructors with different parameter lists. Types of constructors. Default constructor. A constructor with no parameters. The compiler provides a default constructor if you don't explicitly define any constructors. It initializes instance variables with default values, example 0 for numbers, null for objects. Java. Class char. String color. Int year. / default constructor. Char. Color equals white. Year equals 2023. Parameterized constructor. A constructor with parameters. allows you to initialize object properties with specific values during object creation. Java. Class car. String color. Int year. / parameterized constructor. Car, string color, int year. This dot color equals color. This dot year equals year. Example, creating objects with constructors. Java. Class car. String color. Int year. / default constructor. Car. Color equals white. Year equals 2023. / parameterized constructor. Car, string color, int year. This dot color equals color. This dot year equals year. Public class main. Public static void main, string args. Car1 equals new car, / using default constructor. Car2 equals new car, red, 2024, / using parameterized constructor. Important points. Constructors are essential for initializing object state. Use parameterized constructors to provide flexibility in object creation. Consider using default constructors for default object values. Constructors can be chained using the this keyword. Java modifiers, controlling access and behavior. Modifiers in Java are keywords that are used to specify the characteristics of classes, methods, variables, and constructors. They define the accessibility, behavior, and other properties of these elements. Types of modifiers. Java modifiers can be broadly categorized into two types. 1. Access modifiers. These modifiers control the visibility of classes, interfaces, members, and constructors. Public, accessible from anywhere. Private, accessible only within the class. Protected, accessible within the same package and subclasses. Default, accessible within the same package, no keyword required. 2. Non-access modifiers. These modifiers affect the behavior or other characteristics of classes, methods, variables, and constructors. Static, belongs to the class rather than an object. Final, cannot be changed after initialization. Abstract, a class that cannot be instantiated or a method without implementation. Synchronized, used for thread synchronization. Native, method implemented in native code. Transient, not serialized when an object is serialized. Volatile, indicates that a variable's value can be changed by multiple threads. Strict, used to enforce strict floating point calculations. Example. Java. Public class myClass. Private int x, / private instance variable. Static int y equals 10, / static variable. Final double pi equals 3.14159, / final constant. Public void my method, / public instance method. / static void my static method, / static method. / Important points. Modifiers are placed before the element they modify. Multiple modifiers can be used together, but there are specific rules for combinations. Understanding modifiers is crucial for writing efficient, secure, and maintainable code. Encapsulation in Java. Encapsulation is a fundamental concept in object-oriented programming, OOP, that involves bundling data, attributes, and methods that operate on that data within a single unit, which is a class in Java. It's a mechanism for protecting data from accidental modification and misuse. How encapsulation works. Data hiding. Declare instance variables as private. This prevents direct access from outside the class. Public methods. Provide public methods, getters and setters, to control access to the private data. Getters are used to retrieve data, and setters are used to modify data. Example: Java. Class encapsulation example. Private int age. Public int get age. Return age. Public void set age, int new age. If new age equals 0 and new age equals 120. Age equals new age. Else. System.out.println, invalid age. Benefits of encapsulation. Data protection, protects data from accidental modification. Increased flexibility, allows changes to data implementation without affecting the code that uses the class. Code reusability, promotes code reusability by creating well-defined objects. Improved security, enforces data integrity by controlling access. Key points. Encapsulation is achieved by making instance variables private and providing public methods for access. Getters and setters are commonly used for data manipulation. Encapsulation is a cornerstone of object-oriented design. Java packages and APIs. Packages. A package in Java is a mechanism for organizing classes and interfaces into a hierarchical namespace. It prevents naming conflicts and improves code reusability. Key points. Packages are created using the package keyword at the beginning of a Java source file. Package names are typically in lowercase and use dot notation, example com example.mypackage. The import statement is used to access classes from other packages. Example: Java. Package com example.mypackage. Public class myClass. // APIs. An API, Application Programming Interface, is a set of definitions and protocols for building and interacting with software applications. In Java, the standard library provides a rich set of APIs for various functionalities. Key points. APIs define classes, interfaces, and methods that can be used by developers. Java's standard library includes packages like java.lang, java.util, java.io, java.net, and many others. Third-party libraries also provide APIs for specific purposes. Example: Java. Import java.utilityArrayList. Public class myProgram. Public static void main, string args. ArrayList string list equals new ArrayList. // Relationship between packages and APIs. Packages are used to organize classes and interfaces within a library or application. An API is a collection of packages and classes that provide specific functionalities. Common Java packages. Java.lang contains fundamental classes like string, math, object, etc. Java.util provides utility classes like date, list, map, etc. Java.io offers input/output functionalities like file, input stream, output stream, etc. Java.net provides network-related classes like socket, URL, etc. Java.awt contains classes for creating graphical user interfaces. Javax.swing provides a richer set of GUI components. Benefits of using packages and APIs. Code organization. Packages help in managing large code bases. Reusability. APIs provide pre-built components, saving development time. Standardization. APIs promote consistent coding practices. Collaboration. APIs facilitate teamwork and code sharing. Inheritance in Java. Inheritance is a fundamental concept in object-oriented programming, OOP, that allows you to create new classes, subclasses or derived classes, based on existing classes, superclasses or base classes. This promotes code reusability and hierarchical relationships between classes. Key concepts. Superclass, parent class, the base class from which other classes inherit. Subclass, child class, the class that inherits properties and methods from the superclass. Inheritance, the process of acquiring properties and methods from a superclass. Is a relationship, a subclass is a specialized version of its superclass. Syntax. Java. Class superclass. / superclass members. Class subclass extends superclass. / subclass members. Types of inheritance in Java. Single inheritance, a class inherits from only one superclass. Multilevel inheritance, a class inherits from a derived class. Hierarchical inheritance, multiple subclasses inherit from a single superclass. Hybrid inheritance, a combination of multiple and multilevel inheritance, not directly supported in Java using classes, but achievable using interfaces. Example. Java. Class animal. Void eat. System.out.println, animal is eating. Class dog extends animal. Void bark. System.out.println, dog is barking. Overriding methods. You can override methods in the subclass to provide a different implementation. Java. Class bird extends animal. @override. Void eat. System.out.println, bird is eating seeds. Void fly. System.out.println, bird is flying. Super keyword. The super keyword is used to refer to the parent class's members. Java. Class child extends parent. Void method. Super.method, / call the parent's method. Important points. Inheritance establishes an is-a relationship between classes. Subclasses inherit both public and protected members of the superclass. Overriding methods allows customization of inherited behavior. The super keyword is used to access superclass members.